everything you look at for not just Cassandra, for any NoSQL based database, it says don't do this.
Yeah, there's better technologies out there in 2025. It was not 2025.
Especially for like startups, like you don't have time to figure out right. You have only time to figure out good enough most of the time. The maintainers are always very clear. Do not build a queue on top of Cassandra. Do not run Cassandra across multiple regions. Do not run Cassandra in high network latency and variability environments. If we gave you a 200, you knew that data was replicated across at least 2 regions. We were actually always going for 3.
I am so excited to do this episode. On tonight's episode of Tern Stories, we have Arup Chakrabarti. He is former senior director of engineering at PagerDuty. He joined them as the 15th employee and stayed with them all the way through IPO. Before that, he was at Netflix. He was at Amazon. And we have known each other for, at this point, 30 years. So I am excited to hear a story that I have not heard before, which is weird, but welcome.
Well, thanks for having me, TR. Just to kind of give a little bit more context on my technical background. So worked at Amazon, Netflix, PagerDuty, always worked on what I call the behind the scenes teams. So these were always the backend APIs, infrastructure, security, all the stuff that when things run smoothly, no one notices. And when it breaks, everyone notices. So that was my wheelhouse.
PagerDuty was a good place for you to end up.
PagerDuty literally was like the perfect encapsulation of my career in one product in one company.
All right. So what we're going to talk about today is PagerDuty early on used Cassandra, and they used it in a little bit of a interesting way. So tell me, set the scene a little bit for me. When was this? And
yeah, this is, I'll talk a little bit about what kind of even inspired this kind of outrageous use case for Cassandra. So the use case was using Cassandra as a queue, which everything you look at for not just Cassandra, for any NoSQL based database, you will say it says don't do this. Like, do not do this. And the reason that we went down this route was basically, like most companies started in the late 2000s, early 2010s, PagerDuty was a Rails stack built on top of MySQL and a little bit of, we had a little bit of Memcache in there, but we were building a lot of the queuing stuff on top of MySQL, which again, don't build queues on top of MySQL. That's another thing that you see in Flash and Rabbit. And so we had decided to build a queue on top of Cassandra because of some of the tunability consistency guarantees that we needed. So we were running workloads across disparate AWS regions, and we needed the ability to write to a queue, but also be able to guarantee that, hey, we've written this data across multiple regions before we serve back a 200 to the customer. So that was the original inspiration of why we went down this choice.
It was a deliberate choice. So wait, you were using, I'm not even going to let you get to the story. You were using MySQL as the queue before this?
Yeah, basically using like delayed jobs, which was the library at the time, which, worked actually fine for, a couple of transactions per second. For the same, we even got to like tens of transactions per second. You would just start to see write constraints on the disk. And again, MySQL was not designed for this stuff. And so we were using it in a way that while we were getting some of the consistency guarantees, if you think about MySQL synchronous replication, and you think about this idea of like constantly updating state on a single row, all of a sudden you're going to grind the disk to a halt, which is why you don't want to be doing this in general. You don't want to be doing synchronous replication, but in particularly this case was very expensive.
Got it. So you had your MySQLs, you're doing the queue in there, and you had not only had you decided that you needed like multi-region, had you tortured MySQL into multi-region, or was that part of the transition?
I don't remember. I don't think we were using a DRBD based replication mechanism. So for folks not familiar with DRBD, basically it's a block based replication mechanism where you're using at the disk level, you're doing your replication as opposed to the MySQL level. So another way to think about it is like kind of like a fancy RAID device. And again, the nice thing with it actually can simplify a lot of the MySQL operations. But again, if you have a crazy high write throughput, all of a sudden you can start pegging the disk and run into those constraints.
Got it. Okay. So didn't seem like it was a good idea to go with MySQL. You're already running into problems with it. You made this choice to go to Cassandra. Tell me a little bit about like what was like the state of PagerDuty at that time, like user size and.
So company wise, we were like around, that 10 to 20 mark. Number of customers were probably in the couple of hundreds. Like, it was a company that, PagerDuty has such an interesting, usage pattern it's not very seasonal. Like you think about for like a lot of consumer products, it's very unpredictable, very, very spiky, of course. And so, you could actually, we were able to get away with having a pretty small server footprint for a very long time because again, we didn't, our steady state was pretty low. And yeah, we'd have these spikes, but we'd be able to scale up pretty reasonably well. And for that reason, we would over provision it purposely, just to make sure, customers never felt that. So yeah, a couple hundred customers. And, but even at that low volume, we were just running into like, again, these constraints at the database level. And the bigger problem was, we positioned ourselves, and rightfully so, as a company you could trust with your data. We had this thing where if we gave you a 200, that you had confidence not just confidence, that we were making guarantees to customers that data has been replicated across two AWS regions. And so that was something that I think compared to a lot of other companies, reliability and consistency were just so important early on in the company's DNA. And, I credit our founders, but also I credit our customers for kind of placing that trust and responsibility with us, which, we saw as a privilege and obligation at the time.
Yeah, absolutely. I mean, that was both uncommon for SaaS products to promise at that time, and it was still reasonably common at that time for Amazon to lose a region.
Oh, absolutely. And the thing was like, it was something that, when I think about like failure injection, Chaos Monkey, and, PagerDuty, we pioneered this thing called Failure Friday because we didn't have the automation sophistication at the time to deploy something like Chaos Monkey. It was all based on that premise of like, yeah, like regions do fail, servers fail. And, if we fast forward to now, like, yeah, these things fail, but like, it's not nearly at the grand level though. They didn't GCP just have a
Yeah, we're recording this the day after everyone didn't work for 3 hours, so we got to be careful what we say.
So many people, all my friends who work over at GCP right now, but it's true. Like, there were these moments especially in the mid 2010s where like half the internet was just gone for, a few hours. And like, it was a joke of like, all right, folks, like, take the rest of the day off while the folks at AWS are fixing their stuff, and then we'll come back and reboot everything when we can.
Yeah, different constraints a little bit, but the more things change, the more they stay the same. Okay, so Cassandra.
Yeah, so Cassandra. So, for folks not familiar, Cassandra's it's a NoSQL based database that, based on some of the original ideas from the Dynamo paper that Amazon had published, a long time ago. And it was created by, a bunch of different companies and engineers from the open source project and everything. And the big thing was with Cassandra at the time was horizontal scaling. Like that was really where it shined. It would beautifully partition data. And so you could separate your reads and writes, and the big thing that, if you were going from using a relational database like MySQL or Postgres to Cassandra, the big thing that I really had to wrap my head around was this idea that like your joins were in your code now, and that you weren't offloading a lot of the data retrieval and writing. That complexity shifted into the code and away from the database itself. And pros and cons, there's some areas that you create some complexity, but you simplify some of the operational stuff. And, like I was saying earlier, Cassandra, the maintainers are always very clear. Do not build a queue on top of Cassandra. Do not run Cassandra across multiple regions. Do not run Cassandra in highly network high network latency and variability environments. But like I said, we were trying to really create trust with our customers. Again, if we gave you a 200, you knew that data was replicated across at least 2 regions. We were actually always going for 3. But that was the beauty of Cassandra. There was a lot of tunability in the config files. Even early on, we were using it, I think, from 0.8, I want to say. Maybe it was definitely pre 1 dot. And
PTSD inducing version number to put in production.
Yeah. Oh, God. Well, that was the funny thing because Cassandra, especially the early like a minor rep was not a minor rep. Like so much change across each one, and we'll get to the upgrades in a little bit. But like it was because the upgrade, I don't remember the exact version numbers, but like this was technically a minor rep, and it was not. It was not a minor revision at all. But the really cool thing about Cassandra back in the day was the configurability. And so we could put in things into the config files of like, hey, here's when to give back a proper acknowledgement. Here's when you can say the write failed. Here's where you could say the read failed. And that was it was so unique, that was also one of the big reasons we ended up using Cassandra over a lot of other options. And, just to also set the scene a little bit, like things like Kafka and whatnot just were in its infancy. They didn't have consistency guarantees. The horizontal scaling and sharding story still wasn't quite there yet. And the other thing was we just didn't know anyone on the Kafka team at the time. We knew a couple of the Cassandra maintainers. And this is where, like, when you think about technology choices, it's always interesting. It's like there's the quote unquote right decision, but that's such a loaded term, right? Because for us, the right decision came from like, hey, like I had just been working on Netflix, which had done some amazing work with Cassandra. So like I was able to learn from some brilliant folks, knew some maintainers that were working at Netflix. And so through that, and then I joined PagerDuty and did made the decision to use Cassandra before I'd even joined. But what was hilarious was, and just again, one of the things I love about the open source community was how when PagerDuty had started to use Cassandra, we were able to reach out to the maintainers and they were wonderful. They were amazing in answering questions. And there was a lot of the like, wait, what are you doing? Why are you doing that? And then when we explain the constraints and what we were trying to do, they're like, okay, yeah, let's try to figure this out. Versus, there are still open source communities that work that way, but there's still, I don't know, maybe I'm getting a little old and jaded, but like, there's a lot of like, you're holding this wrong.
Yeah, absolutely.
Which frustrates me with certain communities. And, this is where it is that kind of that weird, like, intersection of business and technology constraints. And as an engineer, when you're working on these things, right, is at that intersection. And you got to figure it out sometimes. And sometimes the quote unquote, right, technical solution doesn't actually solve the business solution or the business problem. And you got to figure that out.
That makes a ton of sense. That you're just like, there's better technology. Us sitting here in 2025 are like, yeah, there's better technologies out there in 2025. It was not 2025. And this is true of a lot of things today. Like people building today, I'm sure people building in AI are like, yeah, I get that feeling.
Yeah. And the thing is, like, especially for like startups, like you don't have time to figure out right. You have only time to figure out good enough most of the time. And that means like, hey, you have an engineer that, has some experience with the quote unquote wrong tool, but it's going to be the quickest to deploy and solve it for maybe one order of magnitude of scale. Great. That is the right solution there. And that just gets you to that next, scaling bottleneck, maybe the next funding round. So go, like that's what we should optimize for. And, I think as engineers, sometimes we get so caught up in the technical, right, that we forget what's right for the business. And even when you have these warning signs on the manual that says, do not use Cassandra as a queue, it was actually, again, and I will stand by this, like it was the right decision at the time with the limited resources, the limited knowledge and time that we have.
I I love it. Okay, I know this is maybe reaching. I would love if you could remember any of the specific, like, what did you go to the maintainers with that they were like, what? Oh, okay.
So I think the big one was the cross region stuff, because Cassandra at the time was not designed to run across high latency environments. So when we told them, we were like, I forget what the exact config it was, but like basically like the standard, like I think it was a timeout value. And I think the standard timeout was like in the tens of milliseconds. And we were like, want to do a couple of seconds. And they're like, wait, you want to figure out how to use this thing 3 orders of magnitude time? What? And we explained it to them, and they were very I think patient is the nicest way to say it. They were inquisitive. They were not judgmental, which was pretty cool.
That's great.
Yeah, it was a very, curious. They were very curious what the use case was, and that was, if lack of a better word, it was fun. It was fun to solve that problem with them and to like figure out like, hey, like where's the config file? Because remember, like the maintainers know obviously the standard config file in and out, but there's always hidden config variables, right?
Right. Yeah.
And you dive into the source code to figure that out. But when you can work with the maintainers directly, because like, you can literally just search in the source code and find the values, but you don't want to set it arbitrarily. And so that was really fun to like work with the maintainers at figuring out some of those kind of more obscure config variables that we got to play with.
That's fun. So was there anything wrong with setting that value to like 4 seconds?
It wasn't designed for it, right? So like the thing was, so the biggest thing was writes grinded to a halt initially when we just set it that way. There was a bunch of other variables we didn't set. I think it was like, it wasn't a global timeout value. I think it was just a write timeout value. And so we set it there, but the cluster I remember just grinded to a halt. We think like doing this all on test, and it just stopped working. Basically, you couldn't write to it anymore. And I think from what I remember, it was something to do with like the way that the replication worked. It was kind of like, you could think of the Cassandra replication almost like a ring, and it would basically like go in a certain direction at a certain speed. But if the servers on like the other side of the ring didn't acknowledge the write quickly enough, like every other server is like, okay, we never, like this data never existed.
Oh, sure. Yeah, that makes sense.
And so that's where, again, we had to play with a bunch of, it wasn't just this one write timeout value that we had to play with. There was a bunch of other ones. And as far as I remember, there was some like read timeout values we had to play with as well. Which, again, just, it was the nice thing with working with some maintainers. Also, like I was lucky that we had a couple of early operations engineers at PagerDuty that like were not afraid of diving into source code. Was so lucky and yeah, just really interesting. In fact, there's actually one of the more famous things that one brilliant engineer I worked with, Evan Gilman, he wrote this article on a Zookeeper upgrade, which, it's on the, if you search PagerDuty Zookeeper upgrade, there's some really fun stuff that he wrote about it.
Cool.
That's a different.
It's a different episode. We'll do that in a month or two. We'll do the first like multi-person episode. Cool. It makes a ton of sense that there's like, you have to have like bags of tunability, bags of config that work together. Like,
yeah. Well, and the scary thing with Cassandra too is like we were using Chef to automate a lot of the config generation, and like here's the IP addresses of the servers you're supposed to talk, like that kind of stuff. So it was like a service discovery this up. But what was always so scary about that was there were certain variables that had to be consistent across the entire cluster, and there were other variables that it didn't matter. So in the context of an upgrade, you really had to be careful about not just updating the config file, but like specifically which config variables you're updating in which steps. And if you just ran ran Chef on the server to generate the config file, it just it just updates the whole thing at once. And so, and the thing was, we were trying so hard to avoid these artisanally configured variable files, but we ended up having to do it. Like, we had to SSH to the machine, edit it by hand, and we hated it. We were so annoyed that we had to do it. But we couldn't figure it. Well, sorry, we figured out what a better way would have done. We didn't have time.
Right. And you dealt with the SSHing.
We dealt with the SSHing, and I remember one of our engineers, he had introduced Ansible into the environment, which made that a little bit better. But it was well, and then the other crazy thing with that kind of an upgrade was there were certain config options that were actually stored in the database as well. So there's the config file that you deploy, start Cassandra up, and then there were certain configs in the database itself that you have to, it's basically like a write operation. And so like separating those out too in the whole grand plan of like, how do you upgrade this in production without taking the whole thing down? Absolute nightmare. Because it's just so many things could break, and it just felt so brittle. And again, we were doing things where like the Cassandra maintainers were great. They were like, well, just, treat it like cattle, shoot in that and bring up a new one. But the problem was even though we were operating with not much data, we're talking like maybe 100 gigs, like very small amounts. Right? But when you're shipping 100 gigs across the WAN, it takes a while, right? And that was the problem, was because we weren't working over 10 gigabit links. We were working over the open internet effectively. And on top of it, we were encrypting everything ourselves, the IPsec. So it just, our data transfer was just slow. And so if we actually couldn't treat, at least back then, we couldn't treat everything like cattle because, again, there was a little bit of artisanal work that was being done on every server.
Yeah, it's funny. There's this it's almost easier to think about like state as like, this thing cannot be deleted. It is a pet. It has data on it that if a customer loses that data, we're all going to go out of business. And then there's stateless stuff. But it's all the hard and interesting problems end up being like in the middle there, where it's like, it'd be really annoying if we lost this node.
Yeah. And it's like, again, maybe it's the older I get, the answers to most questions is it depends, right? And it's so frustrating because, when I was writing web apps very early in my career, one of the big things was never store state on an app server. Makes sense. You lose app servers left and right. But let's say you have some highly ephemeral data that you want to, like a local instance of memcache and write it in a single process writing against it. It is hella fast. And there's a lot of scenarios where it makes sense to do that. And if you lose it, that's a bummer. But again, it may be fine because it's a highly reproducible data. But like, to your point though, like where a lot of the interesting problems lie are in that in between zone where it's like, no, this has to end up on a data. No, this is a application server, like this strict separation of church and state. It gets blurry really quickly. And then you think about like when you start scaling up and you're having to like maintain certain levels of performance and everything, this is where those compromises start to kind of creep in. And so then like bringing it back to like a Cassandra upgrade, like this is where like the quote unquote like manual doesn't work because you are introduced so much complexity, and I would argue necessary complexity, because your business is getting more complex. Your customers' use and desires and demands are just more complex than what it was originally designed for.
Yeah, that makes a ton of sense. That at some point you're going to run into some scale problem where you need something that doesn't work with the architecture you designed 2 years ago.
Yeah, and that's okay.
You're deal with it.
And this is where though, like, again, bringing this back to upgrades a little bit, like you still like have to be willing to do that work though. And I think that's where like I definitely got caught early in my career where, we'd introduce all this complexity for good reasons. And, some CVE gets published or there's some new like performance or something. And maybe you forked a library or something, something equivalent of that in your database or whatever, you can't upgrade. And that's like some of the scariest moments where you start going through it. And it's not even about time or money. It's like, you just can't, because you made some one-way decision at some point in time. And that was something we actually did a pretty good job with our databases at PagerDuty, where we always, there's some other parts of the code base where we didn't make the best decisions, but at least with the database, we were like, no, stick with like the main line, like whatever, what are they using upstream? Okay. Bring that in, and then make sure, like, there were times where, like, I remember thinking this, and thankfully my engineers were much smarter than me and they didn't let me do this, where I want to basically like set off our own like config files and like have like our own, and like just like fork the database and like put in our own little logic around that. Or whether it was like replication lag or something, like, no, that's going to make things so much harder later on. They were at 100% right. And thankfully are smarter than me.
I was glad they're there.
I joke all the time that, like, I every now and then I speak about this stuff at like conferences and stuff. And I would, like, the first or second slide was always a giant disclaimer of like, I'm up here talking about this stuff. All the folks that I work with are so much smarter, and thank God that they let me hang around and prevent me from not only shooting myself in the foot, but like also managing to shoot them in the foot too.
Right. Okay. I want to talk about the actual like transition here, because like, so you started on MySQL, you've done a bunch of experiments with Cassandra. Like, how did you actually leg over to it?
So as far as I remember, we actually did take a small little outage. It was one of those things where we had done the we had done the analysis of like, okay, if we do a bleed over, and we realized, like, you know what, this was one of the rare scenarios where it was safer to actually just take, I think it ended up being, we're talking like tens of seconds, like less than a minute. That was a safer route to take. And obviously we have practiced it a bunch of times, and it's terrifying, of course, like, to do these things. But that actual cutover was a multi, probably 20, 30 seconds where we were still caching everything, but things were not being written to the database. And then we flipped it on, it all flushed through, and then everything thankfully worked. So that initial cutover from MySQL to Cassandra was done like that.
That's interesting. So did you publish to customers that you were taking downtime, or was this just like an internal?
No, it was only an internal thing, and we had very high confidence. And I think, like, rightfully so, we had practiced it so many times that we were feeling good about doing it, and it worked.
That's cool. I feel like for those kind of scenarios, the fact that it went well is the testament that you put in the reps. Right, like that. You don't get lucky the first time.
You don't get lucky with these kinds of things, and I credit especially the founders. Like, they cared about the plan a lot, and there was a lot of scrutiny applied to everything from everyone, and yeah, practice. Like, that was the thing. Like, we had scripts. We had a staging environment, a load test environment, and we just practiced on both constantly to make sure that it was going to work. And that's the thing. Databases are hard. Like, this is where, like, upgrading databases and cutting across, like, it's very different from upgrading a code base. And again, obviously upgrading code bases has its own complexities and challenges. I'm not trying to minimize them, but the thing that always scared the hell out of me with upgrading databases was, like, when you start dropping data, that's it.
Yeah. The data's gone.
The data's gone. And look, there were moments throughout PagerDuty's history where that happened occasionally, thankfully not too often, but occasionally. And those were some of the hardest customer conversations I had. It was weird. Where it was a huge trust violation where it was like, yeah, we gave you 200, and that wasn't actually true. And I wish we had sent to 500. And there was just some of these weird edge cases where we did it. And I tell technology leaders, especially in the reliability space, all the time, like, as hard as it is, always be honest with your customers when you screwed up, and they'll be pissed, as they should be. But you don't want to be in the situation where you tell your customers that you effectively lied. And that's a much, much worse position to be in. And that's where, the difference between a 200 and a 500 is that if you served up a 200 and it was a 500, you lied.
Yeah. That's not,
That's
that's no good. It's an interesting kind of distinction to make, especially again, today, 2025. And like, there's this weird middle world of like computers are also agents and they talk to us in English. But like at the end of the day, people aren't doing business with a machine or an AI or a person. Like they're doing business with an entity, and that entity in every way needs to be honest with them. And like, that's both the people they call and yell at, or the people that, or like the machines that give them 200s or 500s.
All the same. And this is where, again, obviously infrastructure reliability, this thing has stuff near and dear to my heart, but it comes down to trust ultimately between the two entities that are working with each other, doing business with each other, calling money APIs from each other. It's trust. And turns out trust is pretty valuable. And, the adage, it's hard to earn and easy to lose. And yeah, like I was in a lot of customer calls where, hat in hand apologizing. And, I could say like, well, look, in the last year we had, 4 to 5 nines of event. Didn't matter.
That doesn't matter.
It doesn't matter. The second you send a 200 when it was actually a 500, you've lost it, which, later down the line actually led to some pretty interesting design choices on our APIs where we were actually pretty harsh on ourselves with our 500s, but purposely so. Because we wanted customers to like, hey, like, we're not 100% sure this was a 200, so we're going to serve up a 500, and we'd rather, duplicate something downstream than say we got it.
Interesting. Yeah, that makes sense. I want to come back to that. I want to, if you sort of look at the moment of, okay, so you did this, you set up your Cassandra, you did a bunch of like interrogation of the actual Cassandra ring, set it up, got it working, gave it the characteristics you want, and then did this cutover. That's, I imagine, y'all are still pretty small at this point, and there's only like probably a couple engineers working on it.
Oh yeah, I think so. Most of them, probably like 7, 8 engineers working on it.
Okay, yeah. So how did, that, like, going back to this idea of like PagerDuty is a monolith to most to their customers, like it just that's the whole thing. How did you have to do any work to incentivize like the rest of the company, or to inform, or did they have to do any work to deal with that, or did you manage to keep everything kind of like below the waterline for them as well?
Oh no, no, everyone was impacted. So while there were 7, 8 engineers primarily focused on it, every engineering team, because so PagerDuty, like most companies, it was this Ruby on Rails monolith that we were starting to tease apart. And one of the first things we were teasing apart was was what we called our notification pipeline, and that was what the Cassandra queue was being used for. And but it was so core to the product, especially at the time. And so every engineer had to do something. And so while there were 7, 8 engineers working on it, pretty much full time for a couple of weeks, but maybe a few months. During that time frame, there were like these small little things like, oh crap, like, this other part of the data model is interacting with the notification pipeline. We have to work with, of course, the one engineer that knows it, because that's what like at startup, right? It's only one engineer, not me. We have to work again to fix that.
Got it. Did you have any, like, what was your approach to that? Was it like people based? Was it tooling based? How did you keep track of that? Because like the company is huge at that point, but it's meaningful.
It was people based. And we had the benefit that there was so few of us that we could kind of do that. But we had some, what were we using at the time? I think we were using Asana at the time. I think it was AccuNote. Sorry, we like went through a bunch of project management systems early days. And we tried the assign out a bunch of tickets and everything. And the problem that like at least I ran into was because I didn't always fully understand like the complexity of the work. I, in hindsight, realized I was oversimplifying the work. And again, I was still, I was managing the team, but like I was still technical enough to be able to look at the code base to kind of figure out and like take some guesstimates. And boy, did I get it wrong of like, looking at the code base and thinking like, okay, here's what I think needs to change. And I would write a ticket based on that scope and everything. And then, the one engineer responsible for that model would come back to me like, what the hell are you talking about? Like, that's not how this works. But it was this, like on my part, just a lot of frustration with myself, actually, of like, why is it so hard to coordinate this stuff? And it was because like, even at a small company, less than 20 people doing, which yes, it was a very sophisticated, hard upgrade. I don't want to minimize that. But the code base wasn't that big. And yet I couldn't reason enough about what this upgrade was going to cost to the handful of other engineers that, again, weren't working on this full time. So they weren't in it constantly, but they still need some work from them. And yeah, I repeatedly got it wrong. And so basically I ended up just like finding tickets with individuals being like, hey, can you please scope this out for me? And so I can start to get a sense as like, I guess, pseudo project manager of like what this is going to cost us fully. And again, thankfully, I worked with really smart people that were like, yeah, this will take me a couple hours, maybe a day or two, but that's it. And so it wasn't that expensive, but each time, like I thought, I'm like, oh, this is something that'll take like, I don't know, 30 minutes to an hour. And again, like I'll give myself a little bit of grace looking back, right? Like, of course, like I wasn't working in that code base all the time. So how the hell am I supposed to know exactly how much an upgrade is going to cost? There's no way I could know that fully. And hell, people working in that code base 100% of the time don't know. And that's what is so frustrating about this kind of work sometimes, where like it literally feels like this like bottomless bottomless pit of work where just you keep digging and digging and digging and finding more work. And it sometimes feels like it's like this like weird n squared cubed n to the n problem of like it just keeps getting bigger and bigger,
like fractal scoping or something.
Yeah, it's even working at some of the larger companies that I worked at, where like you try to come up with some formula like, oh, here's the size of the upgrade. Okay, now multiply this by the number of teams and multiply this by the number of services that each team. It doesn't work.
Yeah, and then square it. I don't know.
Well, my job would always add an order, like time-wise, double it and add an order of magnitude. So you think it's going to take 2 months, it's going to take 4 years.
Yeah, and it doesn't. So why do you think that is? This seems like you are not the only person to say this. It seems like every week we talk about this of like, I thought this was going to be easy. And then I talked to someone. I feel like I referenced this half the shows, but there was someone who's like, we were upgrading from Python 2.7 to 3. And it turns out that actually we were upgrading from Python 2.6 and literally nobody knew that. Like, why do we keep running into this like pit of unknowability?
Okay, I'll give you my cynical take, which is probably a little funnier, and then I'll give you my more optimistic take. My cynical take is just outright hubris, that like we think we know our shit, we think we're so smart and we're so clever. I built this thing, I'm its maker, therefore like I will tell it how much time it needs for an upgrade because I'm the one who built it, right?
That's sure.
Yeah, and it's objective, obviously it's wrong. And I'll couple my optimistic take on it. And something that I would always remind my engineers about is this idea of complexity increases regardless of what you do. That if you freeze a feature set on any product out there, and you think about particularly databases, customers are still using it. And they're going to add more data. They're going to introduce new read and write patterns. They're going to figure out new ways to break your API, whatever that is. And if you think that you can predict all that's it. If you think you can keep track of all that in like a dashboard or something, like I would love to meet you, and I would love to see where you did this successfully, because I just don't think it's possible for human team company to be able to track all of that. And so when I get to this idea of like, upgrades taking forever, and, we joke about it, I think it comes from this place of like, well, the problem got harder without us even realizing it. And that's where like, I actually love that story about the Python 2.6 to 2.7. It's just like, oh my gosh, like no one was keeping track of this. And why should you keep track of it? If it's not hurting you, like if you're not taking advantage of, I don't know, Python 2.7 features, then like, yeah, that makes sense that all of a sudden the problem got harder without you realizing it. And that's the thing, that like, just given time, things just get more complicated. They get more complex, and there's nothing you can do about that. Then when I think about upgrades and these other things, this is our effort to try to like reduce that complexity and I guess even reduce some level of entropy in the systems. But the problem is like, it's short lived, because the second you finish, guess what? Time keeps going. It's going to get more complex and more complicated regardless of what you do.
Yeah, absolutely. That feels right. It's like code bit rots for sure. And just like, you're always creating more stuff you don't know about. Like the world is outpacing you in terms of stuff. And that's coming into this little beautiful walled garden you've created through the open source code you work with, or your users' behaviors, or whatever it
Yeah.
is.
Yeah. And
I buy it. I totally buy it.
and again, like, I don't mean to say that like give up, obviously, like that. I will never say that. And obviously upgrades and doing that kind of work is near and dear to my heart. But I do think as technical leaders, we need to acknowledge that like there's a lot of baggage when we say, hey, this needs to be upgraded. I think about even PagerDuty, when we're upgrading a version of Cassandra, and with the explicit mandate of improving our reliability and improving our customer experience. Like, we're literally a company built on the idea of like, hey, increasing reliability directly feeds into our bottom line, into revenue. And even there, it was hard to justify it sometimes, because of this opportunity cost of like, well, we could do this, or we could build out some other features or some other product that our customers are also asking for. So like, I don't know. I always joke that like I had the best job in the world when I was responsible for reliability at PagerDuty, because I cheated so much. Like, I could just say like, when engineers or other leaders be like, hey, like, why is reliability important? I'd be like, do you know where you work? And I got to cheat. So when people were like, hey, why is this upgrade important? And I could say things like, well, here's how it's going to feed into our reliability. And we had a company culture, like literally even our sales reps got it. Like, I was so stupid lucky to work on this stuff. But then over time, like as just, companies, products, everything just gets more complex. Like I tried very hard to hold myself accountable that I didn't cheat, that I would say like, okay, well, yes, like reliability is important, but here's like the tangible value that I think is going to be adding to our customers. And whether that was, speed, performance, reliability, or things like, hey, like, customers won't have to write into our support team to figure out why they got duplicate notifications, things like that. I tried to hold myself accountable to that, which, even for myself, that was hard to do. Like, there were times where I wanted to cheat, but again, I tried not to. And then I think about every other mortal, every other software engineer, every other technology leader in our industry that, they're advocating and arguing for this stuff. And it's hard. It's very hard. I have a lot of peers who, will ask me for advice, like, hey, Arup, I want to, really push this upgrade through, or, I'm really getting sick and tired of Python 2.6.
Which I'm told we have none of.
And I grill them. I'll put them through the ringer of like, okay, no, seriously, justify this to me. Like, really show me the dollars and cents of why this matters. Because, as we were talking about earlier, the cost is always going to be higher than you think. And that return you better be able to articulate that. Otherwise, you know what? If I'm your CTO, I'm not going to support that.
No, I mean the value, despite being, I feel like the poster boy for you should upgrade your stuff these days. My actual advice to most people when they consider an upgrade is like, do you have to? And the answer for most times is no, because like until it is impacting something that matters, right? Your feature development, your reliability, your cost, your like whatever it is, unless you can peg it to one of those things that matters, like what are you doing here, man?
No, and it's, I work with a lot of early stage startups these days, and the last week questions around like reliability or security is another good one. And I love the intent. I do. Like,
Yeah.
obviously, the stuff that I love and is very important to me, and I built my entire career on it. But I have the same pause, like, what are you talking about? Like, is this really the most urgent thing? Like, do you have to do this right now? And I know that sounds very, like almost reckless. Like, I get that. Like, I understand why people think that. And maybe it is, but the truth is that like, it, it becomes this like almost like a siren song to so many engineers, especially I find engineers or a little bit earlier in their careers, they they'll hear this siren song. Well, if I do an upgrade, I've added business value. It's like, no, that's not necessarily always true. I'm sure there's some benefits tucked away somewhere. Maybe it's a little bit faster, but like, you got to articulate, you got to be able to figure out like, hey, here's the return we're getting on it. Otherwise, as a technology leader, you can't sign off on these things.
Yeah, if you don't know it, then why do it at all? Um, yeah, I'm curious that I love your point earlier about like everything adds complexity no matter what, and like MySQL to Cassandra, 100% added complexity. So tell me a little bit about, you're not done at that point. Now you have Cassandra, you got to operate it. It's on version 0.006 alpha -3. What was how did you think about like tooling in that world? Is that something that you could like lower the cost of incremental upgrades, like, and operating it at that point? Or were you just like, you are now in a world of constant cost?
I mean, I think the latter, unfortunately. I would have loved to.
That would be a good story here. No, I'm kidding.
I mean, I would have loved to. Sorry, I take that back. Like we definitely did create some pretty decent automation based on that first upgrade. And again, we did have this mindset like, okay, we're gonna have to do this again at some point, and build some tooling, and particularly with we were using Chef very heavily at the time, but we ran into so many constraints with the automation. And again, those are self-inflicted constraints. They weren't, I'm not going to complain about it by any stretch, but if I again, I was giving you the example about Chef where it would update the config file across all the servers at the same time, which sometimes could just create havoc on Cassandra. Yeah. And even the operating guide for Cassandra, like a lot of them would literally say like, do not update all the configs at the same time. That's literally what we were doing. And we tried to build in some, I forget what the plugin architecture for Chef was called, but we tried to like build that in ourselves, and we did. I would say we did a decent job of it. I actually think like, we put in a couple of like safeguards and stuff of like, if in upgrade mode, stagger this. And if not in upgrade mode again, deploy all of them. So like, we had some clever tooling and everything there, but it was never to the point where I felt comfortable. Like I never got to the point where I felt like I was comfortable giving the work to like a junior engineer. And that was always kind of like a threshold for me of like when a work has been not solved, but maybe simplified enough to the point you can automate it a little bit more easily, where I trust a junior engineer. There's enough safeguards in place, enough testing or test plans at least. And we didn't get there. And not because I think we could have, but I made the business decision. Like, I just didn't think it was worth it because we weren't doing it often enough. But boy, did that create some brainless, and boy, did that create a lot of risk. And God help us. Like, again, going back to like regions failing and servers failing, like every now and then those servers would die. and we'd have to create this artisanally crafted pet Cassandra server to reintroduce into the ring, and we would watch it overnight as the data replicated across the whale. And it was painful. It was very painful. And we did it because ultimately I do think we serve our customers well. Like at the end of the day, like the beauty of the reason we moved to this model was like we could do all this crazy stuff behind the scenes and customers never noticed. And it was great. Like that was awesome. Like there was no performance impact. If we lost a serve, hell, if we lost a region, like we had designed PagerDuty's architecture to withstand full out region failures, which, at the time was pretty wild, and it wasn't as common as it is now. But that was pretty cool. Like and it happened, right? Like there were a couple of region failures, and we're like watching our stuff, like, hey, still working. That's pretty cool.
Yeah, there's this side, what is turning into a recurring theme of, if you have a fundamentally resilient architecture, you can get away with a lot. You can undertool or swallow risk around doing these upgrades, because if they go sideways, it's not customer impacted. It sucks for you, but that's fine. Maybe I can make the decision today that I'm going to hope to get lucky, and then I'll eat it next week. That's fine. That's my fault.
And the thing is, that took me, and I was lucky that I worked at a couple of larger companies early in my career, because it in a good way skewed me towards this idea that really good resilient architectures are always in a constant state of failure. It's just a little bit, right? There's always something broken. And, if you're a CFO, that's probably terrifying, but but it's true. And I do believe this, that it's like when you have these very loose couplings between pieces of software and at a company, at a business, and you can afford to have these just little breakages here and there, I think you end up creating this amazingly resilient software that actually affords you a lot of risk taking, and which, in my opinion, affords you a lot of innovation. And you can take these big swings if you can, upgrade servers blindly and it doesn't go up, get rid of it. Okay, great. That's resilience right there, right? You can take these big swings in the context of upgrades. And, and I think we understand as well on in-house software, deployed to, let's say, a Kubernetes or some other container scheduler pretty well. Deploy the new software, spin up a whole new set of shut it all down. And, we kind of take for granted that we can take these big swings now, but it's phenomenal that we can do some of these things. And that's because we always assume that yes, something's broken, detect, have the health checks running constantly, take those servers, those containers, those endpoints out, and you could take these big risks, which I think is really cool. But I also recognize it's taken us as an industry decades to get to this point for certain parts of the stack, and databases are hard. I don't think we're there yet for the persistence layer. I think we'll get there at some point. I don't know when.
But being able to do it for the other 80% or 90% of stuff, that's amazing. That
amazing. And the nice thing is we're thankfully not upgrading databases all the time, right? You don't have to do this, and it's usually because there's some new feature set. That was our desire at PagerDuty when we were upgrading Cassandra from minor version. I put it in quotes because those were not minor version. I will die on that hill.
Okay, I want a story. What is what was one of those minor versions?
Pre Cassandra 1.0. They were still I want to say we were going from 0.7 to 0.8, I think, and the entire config file had to be rewritten. What the hell? This isn't backwards compatible. This is not or complying with semantic versioning. That I will give them credit. Once they got to 2.0, that's when I felt okay, 2.1. Yeah, that felt better. But even when Cassandra 1.0 came out years later, again, it was another big rewrite of the config file, and I still think they were a little cheeky with some of the minor rats of it wasn't actually as backwards compatible as I would have hoped. But I will give them full credit. After 2.0, I actually felt they did a really good job.
It was 0.7 to point
Yeah,
8 or 0.07 to 0.08. It's fully
terrifying. It
different.
was terrifying, and like and again, this is one of the cool things of like working with these very I don't know what the right word is, but just like early communities. Like this is what I love about open source, when like you can attach to a project that, has some, had a lot of momentum behind it, of course. And the maintainers and the community was fantastic. They really wonderful to work with. And there were a couple of consultancies that also sprang up around Cassandra that were a delight to work with. There was just so much positive energy. So that made the problem, I won't say fun, but I'll say more tolerable. That you really like there was little bit of the like of shared suffering. So like, I'm complaining about the minor version revving, and everyone, like, it was just like everyone kind of giggled like when we talk about this, like everyone got it.
Yeah, I I mean, this, but I was at a company who was also on Cassandra 0.0 something horrible, and yeah, like it was gruesome to try and debug that thing.
And but again, going back to I will die on this hill. That was absolutely the right decision for PagerDuty at the time to use it in this way, to use Cassandra as a queue to, abuse the crap out of these config files and do these upgrades live, because that's all that, what we didn't have much of a choice.
Yeah, my company was not so successful, so I think yours is a better proof point of the technology. Coming up on time, what does PagerDuty still use Cassandra today?
No, so there's actually, I think it's a happy ending. So PagerDuty deprecated, I want to say all of it shortly before I left. So we're talking almost 5 years ago, and everything moved over to Kafka because
interesting.
Kafka was introduced, I want to say 2018. Yeah, maybe late 2017, 2018.
Sounds right.
And it was so cool to watch what the folks Red LinkedIn were doing with Kafka. And, we, funnily enough, had actually wanted to use Kafka instead of Cassandra when we had chosen Cassandra, but we couldn't get the consistency guarantees out of Kafka. It just wasn't tunable enough. And that changed over time. And Kafka and the folks at LinkedIn were just doing amazing work. And so I don't remember the exact version of it, but very similarly, we had to do this big cutover. Now, the advantage, though, with the way that cutover was architected, was we had taken almost like a multi-primary approach to that work, where we were writing to both the Cassandra queue and the Kafka queues at the same time. And, effectively we were running parallel workflows on top of both. And so we were eventually just dropping stuff with Cat. We didn't actually want multiple notifications going out to customers. We weren't doing that. But thankfully, because we
everything but.
And that just gave us a lot of confidence. So the final product, it was technically like a cutover. It didn't feel like one. It just felt like we were just turning one off, turning one on, but we were slowly bleeding stuff over. And we had much more sophisticated tooling around we could partition customers. So only certain customers were on the newer system versus old. And that was another thing that I'd learned as PagerDuty was getting bigger. At that point it's probably at probably close to 10. Yeah, probably close to 10,000 customers. That while scale and increases complexity, like number of customers and requests, all that stuff, it also gives you a lot of optionalities with upgrades. And it gives you really cool ways where you can partition your customer base. So for example, one of the things that I never fully was able to implement, but we had a free tier at PagerDuty, and what I always wanted to be able to do is hey, these would be the customers that would actually get some of the upgrades first. And not because they're not paying us, screw it. It wasn't that. It was actually these were from a pure risk management standpoint, pretty low risk customers. And it was always an easier conversation with them to be like, hey, we don't, again, if we ever screwed up, I would always be the first one to call these folks, be like, hey, really sorry. And then they'd be like, who the hell's calling us for PagerDuty? That's not look like automated system, but that's a whole nother set of funny stories. We had a B card that we had send out, and one of our office phone lines was in that B card. So obviously most of our customers programmed their phones to like have a different alert tone. And so like whenever I would reach out to a customer, I would tell them like, hey, I'm going to call you at this specific time. So that I should have just called my personal cell phone, but whatever. Um, uh, but what I found, they were very forgiving customers, especially in the context of like if we were, releasing new version, upgrades, something or anything, versus, our Fortune 50 customers, they rightfully so would be so forgiving because they can't afford to be. And that was something that, when I thought about upgrades, whether it was our databases, whether it was app versions, whether it was framework, but whatever it was, it just gave us a lot more optionality with the way we could approach the upgrade versus when you only have 100 customers, you don't really have that as much because it's like all your customers are kind of equal and you don't really know which ones you can kind of piss off a little bit more versus ones you can apologize to and kind of clean it up. And so that was kind of the fun part of getting more scale. And so, so PagerDuty doesn't use Cassandra anymore. That was a lot of engineers did just some phenomenal work. Again, people much smarter than me, thankfully, working on all this stuff that did some great work. And, we started using something that was a little bit more purpose built for queues and queues on top of queues. And the other fun thing with that migration though was it was such a relief culturally, like from a cultural standpoint, like because every engineer, whoever had to touch the Cassandra queue, like you knew it was brutal, knew that anytime you were going to upgrade it, there was always like the magic incantation you felt like you had to do. And it just felt like a wave of like just relief came over the entire engineering organization when those final Cassandra queues were deprecated.
Yeah, that makes a ton of sense. I had this moment where I was like, I should start a company where we measure engineering productivity. And you have to measure that. But you have to be able to measure that feeling of there's not a landmine that I could step on accidentally over here. I have no idea how to measure it, but it's real, like super real.
And the thing is like that fear that comes with touching the Cassandra queue, with touching that part of the code base, which comes with touching that service, it's so much friction in the ways of innovation. And I actually get really frustrated when like people call it like legacy code base. I know, I've shared this joke with you before, or not joke, but like I was on a panel once and one of I forget the guy's name. I think I had said legacy software and he stopped me and so I said legacy software. He stopped me. He says, no, call it legendary software. Give it the respect that it deserves. Recognize that probably a lot of your revenue is coming from that legendary software. And it's scary to touch, but the thing is like, we all have that. Like every company, once you get beyond a pretty small size, you have that piece of software that everyone's scared to touch. And I think it just wreaks havoc on productivity, wreaks havoc on innovation. And this is where I do think upgrades are important. Like you don't want to be stuck constantly engineering around something when it's like, no, maybe you just need to upgrade it. Or maybe, in PagerDuty's case, maybe you have to deprecate it. And the upgrade is actually like a long-term deprecation of a piece of technology. But it's still an upgrade and it's still something that you have to do. I think we could have kept running Cassandra queues for a while longer. We could have.
Clearly worked.
It worked for a long time. It truly did. And that was another interesting thing. Like I remember as we were looking at the Kafka, the upgrade to Kafka, like one of the real tangible arguments we have, like, hey, like the thing is, it is working somehow, even though it shouldn't be, it's still working. Is this still worth it? And, another argument for the upgrade, which I totally was for, was like, look, Kafka increasingly is becoming a common technology. So like we're going to be able to hire engineers that know it more than queues on Cassandra. Cassandra, again, well-established technology, we can hire people for it, but queues on Cassandra, that's that artisanal stuff that, is a little bit harder to hire for.
Yeah. Yeah, absolutely. That was I heard that in one of the first episodes here where we talked about like upgrading from CoffeeScript, and a non-trivial part of that justification was like, I can't hire a front-end engineer in 2018 who wants to work in CoffeeScript. Like, yeah, you can't.
Well, I mean, look at, my favorite punching bag for that right now is COBOL, where there's so many critical systems in this country that run on COBOL, and there's like only like a dozen really
The
prolific.
expertise is literally dying out.
Exactly, and this is where like I know we're supposed to talk about the upgrades, but like I do get excited about some of the AI stuff in this part of the upgrade story of like, and again, I know it's still on there, but like this idea that, hey, I have this COBOL code base. Can you translate all this business logic into insert modern language framework, whatever? And even if you don't end up deploying that thing into production, I do think from like a learning and understanding standpoint for software engineering, I think there's a lot of value in that.
Yeah.
And so I think, again, picking on COBOL, but there's a lot like that. Like even in my lifetime, like I wrote stuff 20 plus years ago in like C or Java or hell, like writing Perl Mason templating that if I were to read that now, I probably wouldn't be able to understand it. So if I could take that code, have it some AI agent bot, whatever, rewrite that into a language that I am just more familiar with right now, I actually would be more comfortable than diving back into that code base in the original language, just because I could build up that context in my head more rapidly.
Yeah, I absolutely agree with you. I think there's a huge amount of, this is the complement to what you were saying of around like the reason upgrades take longer than they should, or really like not just upgrades, right? Like any software engineering project gets misestimated is because there's complexity there that you didn't realize was there. And like even knowing that it's there, we still underestimate how much complexity there is.
That's the thing. And then the worst, it's like, as you're trying to measure the complexity, it keeps increasing.
Yeah.
So planning out the upgrade project, it keeps increasing in complexity literally as you're trying to measure it. So it's like, you're measuring a moving target. It's so hard. It's so hard.
It's so frustrating. But if you can tool up, and I think AI has a huge opportunity here, if you can tool up your understanding faster, like we are not going to do this waterfall. You are not going to have a perfect plan on day one. But if you can always close that gap when you find a new pocket of uncertainty and say like, okay, now I know what's going on there. As soon as it enters your brain of like, oh, there's something over there that we don't know about because we saw an error or someone pointed it out. If you can close that gap really quickly and come up with a plan and update your existing plan and the existing code that you have, the faster you can close that gap, I think that you really do get into a place where it doesn't feel like it's constantly getting away from you.
Yeah. And I, to add to that, I also think if you can reduce the cost of the measurements and like be able to figure out like, okay, like where am, if we think about the moving target, if it costs less, you can measure the moving target faster. I think that makes it easier too. Yeah. And this is where I think some of these AI products out there right now are getting pretty darn good at this. And it's exciting to see how, what once was like a bit of an art, like I've always had, every point in my career, I've had these brilliant engineers that could just like very quickly look at a code base and size it up, and were actually pretty accurate of what the estimates upgraded would be. And I don't know, I think we're not that far off from that being more accessible via these AI, some of these AI products.
Yeah, absolutely. All right, I want to wrap up and do a couple of quick fire questions. So I'll ask a question or say something and just give me the first thing that comes to the top of your head. What is one thing that you wish during one of these projects that you tried to automate that you couldn't automate that would have made all the difference?
If So go back to the Cassandra example. If we had had the ability to automate the staggered rollout of configuration files, that would have made a huge difference.
Yeah.
But we didn't have the automation framework we were using didn't support that. And truthfully, I think we were also just so culturally used to artisanally crafted pet servers. So I don't know if like we even would have used it, but yeah, that would have been it. The ability to automate a staggered rollout of configuration files.
Yeah, that seems like it would have been useful. Oh well. um, what was which customer, internal or external, did you piss off the most?
I can't. Oh man. So this is a bit of inside baseball. So I joined PagerDuty after having worked at Netflix. And so I was a customer of PagerDuty at Netflix. And Netflix was a very early PagerDuty customer. And boy, did we miss them off recruiting at PagerDuty. And you would have thought that, I had some relationships there. I knew some of my former colleagues. Did not matter. They treated us still like a vendor as they should have. And yeah, so there was, they were, and look, they were Netflix was a wonderful customer in so many ways. But when we screwed up, they let us know we screwed up, and it made us better. It absolutely made us better as it made Netflix definitely helped make PagerDuty better, especially in those early days. But oh boy, I dreaded some of those calls.
I love that you switch sides of the table and we're like immediately like, wait a minute.
So the other side of the table, and I'm like, oh my God, why? It's like, there's like those negotiation tactics where it's like you like sit someone in like a lower chair. Like what, like, why is my chair so much lower all of a sudden? Why is he like smell kind of funny on this side of the table? Why am I at such a disadvantage all of a sudden?
The power differential is real, I guess.
It's just huge power differential and different power dynamic of just literally switching sides of the table.
I love it. And because we're here, I appreciate you humoring me and telling me about all this stuff. What are you up to these days?
These days, gosh. So, I spend my time professionally doing two main things. So the first is, I alluded to this earlier. I work with a lot of early stage startups, investing, angel investing, and particularly in like the dev tools security space, which has become an AI space now. And it's just amazing to work with early stage companies and founders. Like I tell people about angel investing. It's a terrible way to make money. It's a wonderful way to get inspired and meet new people. And it's an expensive way to do it, but that's why I continue to do it, is because I get to meet this next generation of founders and people moving the needle on in this area that I care very near, that's very near and dear to my heart. Professionally as well, I work with a company called Fortlight, and we provide management, coaching, and consulting to early stage startups. The way that I pitch Fortlight is when I was first becoming a manager, especially at PagerDuty, this is all the stuff I wish I had known back then. And so, my boss, Amy Riley, she was an early employee at Hotel Tonight and scaled their entire North America operations. And she started this firm because of similar desires. So like, we want to equip managers to do great things, and working as a manager at a startup, it's such a uniquely horrifying, challenging, rewarding problem because we're manual. There's no textbook. There's no MBA program that teaches you how to do it. You learn by literally hearing, "Hey, catch." Or that's it. That's learning. And so we're trying to make that a little bit easier at Fortlight. And outside of that, I spend a lot of time on my hobbies. I've got my keyboard right there. I've got a guitar, a banjo right here as well. And I do a lot of community theater around the Bay Area. So, if you're really desperate for something to do, you can always see me on stage singing, ranting around.
I've seen the posts on LinkedIn, which is I think the appropriate way to promote community theater.
It's it's so funny is I remember when I was working full time, and there'd be icebreakers of like, oh, like, tell us something and you don't know about yourself. And Tiara, you and I have known each other for 30 plus years. You saw me throughout my entire musical theater career in high school all the way to now.
And then your hiatus of 20 years.
But I tell people like, oh yeah, I used to do like musical theater, and it was always hilarious to see the different reactions from people, because some people they're like, oh yeah, I could totally see you like doing it and everything, and especially folks that had like a little bit more of a creative side or a creative upbringing, they were performing upbringing. And then I'd have so many of my engineers who just look at me like, just like so confused and like, wait, what? Like, you would memorize music? What are you talking about? And it was great. And it was so I've been very lucky that, since getting back into it the last couple of years, I'll post to LinkedIn that I'm doing a show, and a lot of my former and current colleagues will come see my shows, and they see a very different side of Arup, which is kind of cool to share.
That's fun. That's super fun. All right. Last question. Where can people find you on the internet if they want to ask questions or get in touch with you?
So if you go to Arup Chak or ArupChakrabarti.com, I own both domains. So both that'll get you all my contact information. Otherwise, LinkedIn, just search Arup Chakrabarti. There's not many of us. It's me and one other guy in India with the exact same spelling. So you have a 50-50 chance of getting the right one.
I will dig up the link and we'll put it in the video description. So make sure to get that right.
Very thankfully, my Google SEO is very good. So it's easy to find me online.
Yeah, beat him. All right. Thanks so much, Arup.
My pleasure, Tiara. This was an absolute blast, man.